Testing, testing. Testing, testing. Let's do 64. All right, so I think we're gonna get started. Can everyone hear me? Can I get a thumbs up in the chat if everyone can hear me clearly and see the slides? Give it like 20 seconds for the delay. All right, I'll take that as a yes. Okay, cool. So let's just get started then. So welcome back. This is part 2 of the Flutter series. So today we're going to take all of the basics that we talked about last time and actually try to build a basic weather application with them. And we'll talk about how to hit a REST API, pull data from the server, serialize the JSON into objects, and then display those objects to the user. So there's a lot that we have to cover. And I'm gonna have to go decently fast to get through it all, but don't worry, all this code is already on GitHub, so I'll have the link to the code. But before that, let's just quickly go through. If you don't know me, I'm Felix. I'm a software engineer at Very Good Ventures. I've been doing Flutter for over 2 years, full time. And yeah, you could check out some of the projects I work on GitHub or follow me on Twitter. And definitely feel free to reach out if you haven't already on LinkedIn, and we can connect on LinkedIn. So if you have any questions, you can reach out in the future and stay in touch. And as I mentioned, this project that we're going to be building from scratch is already finished. You can download the full code right now and run it if you wanted to on GitHub. So don't worry if you're like not able to follow along, or if it's going too fast for you, you can always rewatch the video at your own speed and or at your own pace, and yeah, and follow along. Let me just make sure. Can everyone see the full slides, or are they cut off? They look cut off to me. Let me resize the slides. One second, so everyone can see everything. All right, hopefully that should work. There's a delay, but I'm going to give it a second so that everyone can see the link and make sure that you can go and yeah, download the code. Also, yeah, thanks for posting it in the chat. So yeah, basically, without further ado, like that's the link. You can go to it now and clone it, or you can follow along, or you can just watch, sit back and enjoy. We're going to switch immediately off to VS Code, which is my editor of choice, but you can also do this in Android Studio or whatever you prefer as your IDE. And we're going to basically start off with what you always start off with when you're making a new Flutter project, which is I'm going to make this on my desktop and run the Flutter create command. So we're going to do Flutter create, and I'm just going to call this simple weather. And with that, we should have Flutter. Once you have Flutter installed, obviously, you need to have Flutter installed in advance. But now, since I already have Flutter, it's going to create all of the basic project code that I need. And it's going to create a folder called simple weather, since that's what we named it. And yeah, and now I should just be able to open on my desktop simple weather. And hopefully everyone can see that. I'm going to give it a second and make sure that everyone's seeing the correct VS Code window on the stream. Cool. Okay, looks like everyone's seeing the correct one. So couple things that I always do when I'm going to make this a little bigger so everyone can see better. First thing we need to do is clean up the pubspec.yaml file. So for those of you who don't know, the pubspec.yaml file is kind of like your package.json file if you're familiar with like Node.js, and it basically defines all the dependencies of your package as well as metadata about the package. So in this case, we can delete a bunch of this information and clean it up so that it's not full of comments. We're going to be using Flutter, so we're going to keep that, but we don't need the Cupertino library in this case. And then I'm also going to delete the testing dev dependency, since we're not going to cover testing in this talk, but we can do that potentially in a later talk. And so now we have like the bare minimum package.json. So we have the name of our application, we have a description. Maybe we can call this like an awesome Flutter weather app, right? And then it's going to be version 1.0, build number 1. That's what the +1 stands for. And we're going to be using Dart greater than version 2.7, which is fine. And then obviously we have our dependency on Flutter. And this last one, use material design, that's going to give us access to some material design icons. So that's all that is. And with that, I'm going to wipe out the test folder. Like I said, we're not going to cover tests in this one, but we can definitely cover testing in a separate lecture if anyone's interested in that. And I am going to start off by creating some of the basic like directory structures that I think make sense for this project. So in order to actually build this weather app, we need some different components, right? Like we need the API. We need to integrate with some REST API that we mentioned. We need basically the application code itself. And then I'm going to create something called a service, which is going to basically be responsible for sitting in between the API and the backend, or in between the API and the application, sorry. So let's create folders for all that. So we'll have an API folder. We're going to have a service folder. And then we're going to have an app folder. And so our app folder is going to have all of our Flutter code. Our API folder is going to have all of the API code. Our service folder is going to be responsible for interpreting the API code and giving us a nice model that's easy to work with in the application. So we'll get more into those details. Don't worry too much. Before I even go any further, I want to make sure everything is running properly. So what we can do is we can actually in VS Code create a launch.json file and say I want a launch JSON for Dart and Flutter. And then I'm going to pass it some arguments and say that I want it to run on device Mac OS. And then we can call it whatever, Mac OS, doesn't matter. Save it, and now we have this little play button with Mac OS at the top. And so when I run this, it should run the default main that's generated by Flutter Create for us in macOS. So I'm going to go ahead and do that and make sure that everything's working and everyone can see, and then we should be able to get started. And I'll check on the chat and make sure if you have questions, feel free to ask them as we go. Happy to try to answer them. And yeah, so far it looks like no one has any questions. And we're building the macOS application, as you can see. The first time takes a bit, but after that, it'll be really quick. Oh, and one other thing I want to call out before is in order to actually run on macOS, I'm on the master channel of Flutter. So that's something that you have to keep in mind. So I'm going to add, let me see, I need to add my, my Mac application. And let's see, ooh. 1 second. Let me remove this. Window, here we go. All right, so Mac app, and then let's do that. And then we need to do, which one is this going to be? Is it this? I'm going to have to guess now which one is going to be the Mac. There we go. Perfect. Oop. All right, so save that. Hopefully this is huge, but let me make this a bit smaller. Oh, not that. This guy. Bear with me for a second while I rearrange everything. Here we go. There we go. Let's keep the aspect ratio, and I need to figure out where to put this. So maybe we'll put it here in the bottom, something like that. We'll see how it goes. Hopefully you can see it. and I'll try not to code too far over to the right so that you can see all the code at all times. So yeah, basically, with that now we have this Mac app, right, where we can basically click the button to increment, right? Nothing special. So that's fine. But we're gonna basically end up wiping out all this code now and building the weather application on top of this. And so I think I'm gonna start at the API layer. So the API layer is probably the most important part because you need to make sure that you have a solid foundation that you're building your application on. So I'm going to quickly jump into the API that we're gonna be using. It's called MetaWeather, and you can go to metaweather.com/API if you want to check out the docs. Let me make sure everyone can see that. So yeah, so in MetaWeather, we have a bunch of stuff that you can, a bunch of information that you can access from their API for free, which is why I picked it. You don't really need an API key or to create an account. And you can see they have endpoints for, the endpoints we're going to be using are the location search endpoint. So that allows you to type, like, for example, a city name like Chicago and get the location information for that city. And then there is a API that allows you to actually get weather for a given location by location ID. So we're going to be using both of those. Okay. And so let's just get started. And in our API, we're going to basically start off by creating a MetaWeather API client.dart, right? And I'm just going to call it exactly what it is, MetaWeather API client. And the first thing we need to do is we actually need to have a dependency on an HTTP client, right? Because we're going to need to use the HTTP client to make HTTP requests. And so we're going to have to add our first dependency. So we're going to go back to the pubspec.yaml and add the HTTP library. And I believe it's 0.12.1. Let me double check the version. Yep. So if we add the HTTP package, we should see the little, oh yeah, let me switch back. Of course, this is going to be a pain for me to remember. There we go. So all I've done is I have added the HTTP package to the dependencies of my project, and then I have hit save so that it fetches everything. Yeah, sorry, I didn't switch to VS Code right away. And so yeah, I've added the HTTP package to the dependencies, and I've created the MetaWeather API client class. So that's all we have right now. And now we can, at the very top of the MetaWeather API, import package http.dart, and we'll name it HTTP. And our MetaWeather API client is going to need to have an HTTP client as an instance. So we can say we need an HTTP client. We're going to call it HTTP client. So it's a final private member variable. It's private because it's underscored. And we can add a constructor for our class. And this constructor is going to take an HTTP client. And then we can make sure that the HTTP client that's passed in is not equal to null. And if it's not equal to null, then we can assign it. So we have our API client. It has a dependency on an HTTP client. And we will assign the HTTP client that's passed in to our internal HTTP client as long as it's not null. If it's null, we're going to throw an exception right away because we need an HTTP client. It's absolutely necessary. The next thing that I want to do is I want to define the actual base URL for the weather API. And for that, we can make it a constant. So we can do a static const base URL. And that's just going to be metaweather.com. And that is just from the website. So you can see on the web page. Let me switch over really quickly so you can see what I'm talking about. All of this stuff is accessible through metaweather.com. So for example, if I do a test like location search in my browser, I can do metaweather.com/API/location search query Chicago, and you'll see that we get back this JSON, right? We get the name Chicago, it's a city. We get the ID of the location, which is what we care about, and the Lat Long, which we're not going to worry too much about right now. So that's the first API, but the base URL you can see is www.metaweather.com. So that's that. So now let's switch back to VS Code. And cool. So the first thing I said that we're going to need to do is implement the actual location search, right? The thing that I just showed you in the browser. So in order to do that, we're going to define location search, right? And it's going to take a query. We saw that you need to pass in the city name like Chicago. And we can build the request by doing our location request equals, it's using HTTPS. So we're going to create a URI. We're going to pass in the base URL. And then the path is going to be the location search path. So let me just get that quickly and drop it in. Cool. And then our query parameters that we're going to be passing in are query. So we have our location request. And then we can use the HTTP client that we have to actually make the request. So we can do location response equals, and we're going to need to await because this is going to be asynchronous. So I'm going to mark this function as asynchronous. I can use the await keyword and call HTTP client.get and make the location request. And now at this point, we've made the request, so we have to be good and check. So let's check if the response.status code is not equal to 200. So if something went wrong, we need to throw some sort of failure, right? Some sort of indication to whoever's using this that something went wrong with the API call. So we can make a simple exception called location ID, I don't know, request failure, and we can implement the built-in exception. And for now, we're not going to really worry about passing too much information. We're just going to throw location ID request failure. And now at this point, we know that we have a 200 and we need to actually get the body. So we can do final location JSON, right? That's the body is going to be JSON. So we can do a JSON.decode. And there's built into Dart a convert library that gives you things like JSON.decode. And then we can pass in the location response.body. And in this case, it's going to be a list. So I'm going to quickly switch back to the browser so that you can see what I mean by it's going to be a list. You see how the JSON is actually an array of locations, so it could potentially have more than one result. In this case, we're just going to keep it simple and take the very first result, but we still need to cast our response body as a list because it's not just a JSON map, it's going to be actually potentially multiple items. So that's why we're making it a list. And yeah, so we have our list. And now we need to figure out, basically, do we have results, right? So the first thing we can do is we can check if location JSON is not empty. Let's just do the is not empty case. So if it's not empty, we're going to parse the result and then return it. Otherwise, we can just return null, right? If the result is empty, we don't want to try to parse anything. We just want to tell the user, like, there is no location for this query that you've made. And the reason I'm using this question mark here is location JSON could potentially be null. So this is just like a safety check. So if location JSON is not null and it's not empty, that means we definitely have some data. We're going to have to try to parse that, right? Otherwise, we're going to return null. So far so good. Now the hardest part about this actually is if you're doing this manually, now we have to actually figure out how to represent this JSON object as a Dart object. And so I'm going to go ahead and create a folder called models. And here's where we're going to keep track of all of the API models. I'm going to pause really quick and check and make sure if anyone has questions. Okay, cool. So yeah, 200 is the success status code. So 200 means okay from the server, like everything went well. So yeah, it's a good thing to call out. That's why we're checking. If it's not a 200, that means that something went wrong. So yeah, it looks like everyone is still following along, no major questions. And so we're going to go ahead and define those models. So the first model that we're talking about is we need to model this location object, right? So I'm going to create location.dart, and I'm going to say class location. And when I am saying we need to model the location, I'm referring to this object here. So location has a title, it has a location type, it has ID, and then it has a lat long. So all of that is what this API is defining as a location. Okay, and so we need to basically figure out how are we going to represent that as a Dart object. So as a Dart object, if I switch back to VS Code, we can say that a location has a bunch of stuff, right? We said that it has a title. So let me do this final string title. We said that it has a location type. So I'm gonna define the location type above. So enum location type, and we said that it can be city, it could be a region. This is all coming from the API documentation, so don't worry too much about this. It can be a province, it can be country, or it could be continent. So one of those values, right? We have a title, we have a location type, and I spelled location type incorrectly, of course. Location type. And then we also have what else? We have the ID, right? So we're calling that, oh, it's an integer. We're calling it a WOEID. And then we also have a lat long. So let me define a lat long. We're going to define a lat long. And lat long is going to be another class. And we're going to just keep track of the latitude and longitude, right? So double latitude, double longitude. We're going to add a constructor to all of this. I'm going to make these named and required just because I think it's easier to read, especially because they're the same type. These are both doubles, so it's a little easier to read this. So we got that. I'm going to add a constructor again for location. And let's do one of these. We can make everything named by wrapping it in curly brackets. And then we can make everything required by adding the required keyword. So far so good, right? But now we need a way to basically create a location object in Dart from the JSON that's coming back from the API. And you could do this manually. You could do something like here, we can do like return location. If we import location, oh, one thing I forgot to do is I like to create like a exports file. So I'm going to create models.dart and export location.dart. And that way, if I have multiple models, I only need to import models.dart. I don't need to import one by one. So here we can import, and I'll do the same thing actually for API so that we're consistent. So API.dart, and we're going to export models, and we're going to export meta weather. Oh, doesn't like me. There we go. Cool. So now we can import this location from API/API. And we could manually do stuff like what I was saying, like title. We could do location JSON dot first, and then we could try to access title like this and do this for each of the properties, right? And this is totally valid, like you can do it, but it's a huge pain and it's very error prone because I can accidentally make a typo here or I can not forget to like check for a null or something, and then my whole code will crash. And also, this is very boring and tedious to do, especially for really big JSON objects or JSON responses from the API. So I'm going to show you how to do this automatically using code generation. Let me pause and make sure. Oh, we have a question. Okay, so how does the query retrieve the current location? So we haven't gotten there yet. All we're doing right now is we're defining this API, and we're saying that we're going to pass in the query. So um, the query is passed in as a string to this function that's being called. So we're not getting the query from anywhere yet. We'll get to that in a second, but good question. So like I was saying, we need to basically handle parsing this, but we don't want to do it manually because it's error prone. So for that, I'm going to add some libraries. One of them is called Json Annotation, and I'll show you in a second how to use them. So we're going to add Json Annotation, and Json Annotation needs 2 dev dependencies. And a dev dependency is something that's not needed when you're actually building your application. It's only needed while you're developing your application. And so the 2 dev dependencies we need are build runner, which is going to do some code generation for us, and JSON serializable, which basically has the JSON serialization specific code that I'm going to show you. But build runner is needed usually whenever you have any code generation. So I'll show you how to use all this, don't worry. So I'm going to save the pubspec.yaml. And again, JSON annotation and JSON serializable are you need both hand in hand. One is for the annotations that we're going to add, and one is for the actual generation step that's going to write all the JSON parsing code for us. So with that being said, the last thing I'm going to add is this build.yaml file. And build.yaml is basically a file that JSON or that build runner will read. So we added this package build runner. You can read more about it on pub.dev or on GitHub. It's maintained by the Flutter team, and it's a package that's really widely used. So whenever you have build runner, you can define a build YAML file, and it's going to tell it for each of your code generators that you have in your project a bunch of global options, so that we don't have to specify those every single time. And so in this case, we always want to rename our fields using snake case because that's like the standard JSON convention. In this case, we're only worrying about coming from JSON to Dart and not Dart to JSON. So we don't want to actually go backwards. So we're going to skip that step. And we're going to do checked true, which is going to validate the data and make sure that it's actually formatted the way it is. This is just like a safety thing. And so with that all being run, or with that all being added, we can now come back to our models and we can start annotating our models. So I can annotate a location with JSON serializable. It comes from the JSON annotation package. And if I hit save, let me open a new terminal. Let's see, this is going to be interesting because I'm going to need to add another window, but that's okay. So give me a second to share this other window so that you can see what I'm running in my terminal, because we're going to want to run this in parallel. I don't want to stop running the Mac stuff. So give me 1 second. We'll add another video source. And we'll say terminal. And let's see, where are we? Perfect. All right. So I'm going to throw, we're running out of space here, but it's okay. I'm going to throw this guy temporarily. I'll turn this off in a second, but I just want you to see the command that I'm running. So in here now, we can do flutter pub run, build runner, watch. This long command, don't worry. All it's saying is I want you to run the build runner command, which is the thing that does the code generation step, and I want you to run it in watch mode. And what watch mode means is basically whenever any changes happen, whenever I make a change to a file and hit save, it's going to automatically run the build runner command and update everything. So if I just run this, let me keep that in there. And we give it a second. because the first time takes a little bit. It should, yeah, there we go. So it's starting to generate a snapshot of our code. It's analyzing everything. Um, and it's going to basically start watching all of our files for changes, and it's going to look for this annotation that we have everywhere. And one thing that I forgot to do is we need to add this part statement, which is going to say put all of the generated code, or which is going to say all the generated code is going to go in this .g file. That's just standard from the JSON serializable package. And this part is saying basically drop in all of the JSON serializable code that's generated and pretend like it's part of our location.json file so that we can access those functions that get made for us from within this file. So, so it failed. It failed because lat long is not JSON serializable as well. So we need to add JSON serializable as well. If I save, we can see build runner succeeded. And now you can hopefully see this location.g file was generated for us. And it gives us a location from JSON, which handles parsing, validating, checking all the JSON automatically for us. It's all this code that was generated, which we would normally have to write out manually. It's done automatically for you. And one thing that we're missing is we're missing a lat long from JSON. So I'm just going to drop that in there because I want to save some time. But basically, we can write our own custom lat long from JSON because the server gives us back like latitude, comma, longitude. So our custom from JSON will just split on comma and then create a lat long object from that. So don't worry too much about this. Again, all this is on GitHub. I just want to try to get through as much content as I can, as quickly as I can. And the last thing we need to do is we need to annotate our enums so that we can tell basically the JSON serializable package what names to use for these enums, because enums are just backed by integers. So we can do city, region, state, province. These are just the names that the API is returning. And we're telling JSON serializable, whenever you see the value country from the API, convert it into location type, continent, convert it into location type continent. Or whenever you see location string country, or type country with the string country, capital C, then convert it into the enum location type dot country. So we're telling JSON serializable how to actually handle those enums. And you can see as soon as I save, it should have, hopefully, let me save again. It's hopefully going to rerun, question mark. Oh, actually, it already did. Yeah, so it created this enum map that's mapping all those things to the appropriate string values so that they can get converted to enums properly. And then I think that's all we need for the location. So now with all that generated code that got made for us, we can create a factory method that says from JSON, whenever we get a map, right, because JSON is typically just a map, we can basically call the generated function location from JSON, right? And this location from JSON is made for us by JSON serializable, that package that we added. So it's doing all of the checking that we would normally have to write manually. So I'm going to switch over. No more questions so far. I know I'm going fast. I apologize, but there's a lot we have to cover. And so now that we have our location object, we no longer have to do location blah, blah, blah manually like this. We can just do return location from JSON, right? Because we expose the factory, and then we can say location JSON dot first. Hopefully. What is it complaining about? I forgot a comma up here. There we go. So pretty much are done with the location search part. So now we can basically make a call to our MetaWeather API client, pass in a query. It's going to make a HTTP GET request to /API location search. It's going to add question mark query equals whatever we passed in as our query. And then we can fire off that request. If we get something that's not a 200, meaning the request is bad for whatever reason, then we're just going to throw a failure for now. And then if we do get a 200, meaning everything went well, we're going to decode the entire response as a list because it does come back as a list. And for now, if it's not empty, we're going to take the first element and make a location out of it using our generated code. If it is empty, we're just going to return null. That means we didn't get a location back. So far so good, hopefully. We need to make one more request. So I'll show you, let me switch over to the browser. So you see here, we made the request with the query, right? We said query is Chicago, and we got this ID back. So now, in order to actually get weather information about Chicago, we need to do a location with that location ID. And if I make this request, we get a ton of information back about, like, is it raining? What's the wind direction? What's the temperature? What's the wind speed? Blah, 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 blah. Like, we have all this information. And so this is really like the call that we care about, but we can't make this call without knowing what the location ID is, which is why we need to expose that very first API. So now we need to expose this endpoint in the MetaWeather API client. And so it's going to be very similar. I'm actually going to drop in this code for the sake of saving time. It's going to look very similar. And actually, before I do that, I'm going to define the model. So we're going to need a weather model, weather.dart. Let me switch back over to VS Code so you can see, because I always forget to do that. There we go. And so I'm just going to drop in all this code. It's going to be more of the same stuff, nothing new here. So I'll start at the beginning. We're, again, going to generate this code. So we're going to need this part statement saying whenever you have the generated code, include that generated code inside of here. We don't need this. And I'm going to save now. So build runner is going to rerun, immediately generates our weather.g. And so now we're exposing all of the information that the API is returning, like the ID, what's the state of the weather, like rainy, sunny, blah, blah, blah. The actual enum that represents that. So we define snow, sleet, hail, all the stuff that's returned by the API. And again, we're using that JSON value that we used from location to tell the JSON serializable package, this string value corresponds to this enum. So whenever we get SN back from the API, that responds to snow. Whenever we get SL, that responds to sleet. And all that's coming from the API documentation. Again, like I didn't make this stuff up. It's all documented on metaweatherapi.com. And we get a bunch of other information, right? Like we get the minimum temperature, the maximum temperature, the temperature, that's what they call it in their API. I just kept the naming consistent with what MetaWeather's naming is. But yeah, we have this giant object now. And we have all of this stuff generated to serialize and deserialize. And so I'm going to drop in the code for the API client again, just for the sake of time. But it's literally the exact same as what we did for location. So I'm going to have another method called getWeather. I need to add weather to the models, weather.dart. And then we're going to make a request this time to API location ID, because we take location ID as input property or input parameter. We make the get request. If it's not a 200, we fire off this request failure, which I can define up here. Implements exception. And then if it is a 200, then we can decode the consolidated weather. Again, we're just taking the first piece of weather from that list and calling weather from JSON on it so that we can build the weather object out of it. And that's pretty much it. Like there's nothing else going on here. It's just the same as the location. And so at this point, we have our MetaWeather API client, which exposes all the data that we need to build our application. So I'm going to move on to the service section. And like I said before, the service section is going to basically be responsible for using this MetaWeather API client and actually exposing like an easy to use interface so that in our Flutter application, we don't have to know about all of the inner workings of this API. So I'm going to pause, make sure there are no questions. Yeah, so we're going to start with the UI part very soon. Once I finish the service, we're going to do the UI. So basically going into the service code, I'm going to try to go quickly through this. So we're going to define a weather service.dart. And I'm going to basically say our weather service is going to be just a class that needs a MetaWeather API client. So I'm going to import simple weather API, and I'm going to say we need a meta weather file. Let's see, did I export? Probably forgot to export the actual. Oh, I did. Well, let's just start typing. Meta weather. Maybe my VS Code is being weird. API client. Yeah, it is. So I'll just call this weather API client to be consistent. And then we're going to do a similar thing that we did before where we make a constructor. This constructor is going to take meta weather API client. It's going to check that that API client is not null. Weather API client is not null. And then if it's not null, we're going to assign weather API client to weather API client. Right, so nothing new. Now, the cool thing here is we don't have to now worry about all the details of how to get weather, right? The application only cares about one thing, and it's give me weather. So I'm going to define what we care about as weather in our application. So I'm going to make another models directory. I'm going to do another models.dart, just like before, but this is our service model. So this is going to be what the application is actually using. And this will allow you to have a separation between what the API gives you and what the app is using so that you can swap out APIs later and you don't have to change all of your code. So we can define another weather model. We're not going to need JSON serializable. I'm just going to drop in the code here. So let's say for our application, we only care about the name of the location, the temperature at that location, and then the condition. So is it clear, rainy, cloudy, snowy, or unknown, right? One thing that I actually think I missed in the API, let me just double check, is did we handle unknowns? I think we did, because I dropped this code in. Yeah, we did. So if for some reason like the weather information is not one of the values that we've defined, we're just going to have an unknown. Same thing for the wind direction. This is good for cases where you're not sure what the API is going to give you. Like if you're not 100% sure it's always going to be one of the values that you know of, then you can have a default value. So that's what we're doing here. And because of that, we have just like an unknown case here, just in case. And so we have our weather model. And now we can say our weather service is just going to give us our own weather model back, right? We're going to say get weather. And we care about give me weather for a city, right? So string city. Again, this has to be async. And I'm going to export the weather model from the service here so that we can import everything nicely. I'm going to add exports file for everything so that it can just be all grouped together nicely. Don't worry too much about this. This is just to make the imports cleaner. So now I can import service/service. And now here, this is the important part. So what we're going to do is we're going to get the location, right? So we're going to await, this is coming from MetaWeather, location search, and our query is going to be the city. And then we're going to get the weather, right? So weather equals weather API client dot get weather, and we need to give it the location. This should autocomplete. Oh, we didn't update the return types. So this should give me a location, and this should give me weather. Always specify your return types. So now I can get the ID here, right? And the last step is we need to convert this weather object from the API into our own weather object. So we said that we want the temperature, and that's going to come from the API's the temp property. We said that we want the location, and that's going to come from the location title. And then we said that we want the condition. So here we need to convert the weather condition into our own conditions that we've defined. So I'm going to go over something really quickly called extensions in Dart. So whenever you want to basically manipulate an existing class, if you want to add properties or methods to it, you can write extensions. So I can say extension on API weather state. And then here I can say I want to convert this weather state into a weather condition and call this like toCondition. And here I can switch on the value of the weather state because it's an extension on weather state. And I can drop in all this code that I'm not going to make you watch me type. So here we go. Basically, If we get a weather state clear from meta weather, we're going to convert it to our clear condition. If we get snow, sleet, or hail, we're going to convert that to our snowy. If we get thunderstorm, heavy rain, light rain showers, we're going to convert that to rainy. If we get blah, 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 we're going to convert it to cloudy, etc. Right? So now here we can do weather dot weather state to condition. And so here we're normalizing the data from the server to match our own definition. So this allows us to basically convert all this like complicated, maybe not the best formatted data from the API into something that's really nice to use. And so with that, we're pretty much done. We have our service, and we're going to move over to our main now. So the first thing I'm going to do, this is now starting Flutter. Oh, question? Can I explain what assert does? Good question. So assert is basically something that's only executed when you're running the app in debug mode, and it allows you to make sure that things are true, or assert that certain conditions are met. So for example, here I'm asserting that weather API client is not null. So if I'm running this app in debug mode like I am right now, and I pass in a null weather API client, the app is immediately going to crash and say assertion error, weather API client was null on whatever line. And it's like a really good safety check to do, so that when you're developing, you have like a sanity check to make sure, like, I know from this point forward, weather API client cannot be null. I don't have to worry about checking if it's null here, 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 whatever. I can just have that assert statement at the very top, get it over with. Like after this point in time, weather API client has to be defined. And then I'm confident in the rest of the code that everything, that the condition has been satisfied, whatever condition. This could be anything inside of the assert. And in production mode, asserts are ignored, so it won't crash your code in production. But it's a good thing to put in when you're developing, because it's basically like helping you in case you forget to like define things where they should be, or pass in properties that are required and things like that. So good question. That's what assert is for. And like I said, we're going to start on Flutter now. So I'm actually going to delete everything in the main, and we're going to start over. So in our main, we're going to need to create basically all the stuff that we just made, right? So I'm going to import HTTP package http.dart. I'm going to make an HTTP client. HTTP, oh, I need to name it to make it nice. Yeah, http.client. So I'm making a new HTTP client here. Why am I making a new HTTP client? Because our weather service needs one, and our weather service needs, or our weather API client needs one. So you'll see, all this is going to hopefully make sense. So if I create our weather API client, meta weather API client, this should just be api.dart. So our meta weather API client requires, if you remember, an HTTP client. And then if we create our weather service coming from here, our weather service requires a weather API client. So we've basically built up all the dependencies. And so now at this point, we can do the typical run app, and we'll need to create our weather app and pass in our weather service, right? So that our app has what it needs. So let's start defining our weather app, right? So I'm gonna go in app. We have another question. Let me check. Another question. Why are you using export keyword and exporting Dart files in a separate file? Good question. So let me just do a quick example. So if you look here, this API.dart is exporting models and API client. If I didn't have this file, let's assume this file didn't exist. Now here, I need to actually import the meta weather API client. And if I also needed the weather model for some reason, I would need a separate import, simple weather, whatever, weather API models, location.dart. And if I needed another thing, if I also needed the weather, I would have another import. And so basically these files that are exporting all of the public things that we care about are just preventing us from typing all of this. And instead I can just have one import for all of those things, which is api.dart. Oops. So it's just something that saves you some typing, and also makes it easier if you start moving stuff around. You don't have to change a bunch of imports. You only have to change the one. Or you only have to change like the internals, but this stuff is all going to stay the same. So it's just a convenience thing to prevent you from having to import a bunch of things one by one all over the place. But there's nothing wrong with if you don't want to have these export files, you don't have to have them. Everything will still work the exact same way. So good question. Now I'm going to go into the app. So let's again create our weather app. And this is where the fun begins, right? So I'm going to create a stateless widget. I'm going to call it weather app. And we're going to say that our weather app needs to take a weather service, right? Let's import weather service. There we go. And I'm going to add a constructor. Cool. So we have our weather app taking a weather service. So now in main, I will again add the app.dart because we're going to add more things to our app. So to make it easier to import, I'm just going to add the one import. And what is it complaining about now? Oh, this is named. So that's named because in here, everything is in curly brackets, right? And I'm going to make it required. And again, I'm going to assert that it's not null for safety. And I'm going to do a hot restart to make sure that our app is behaving properly. And look at that. We have a nice black screen, which means everything is working because we're not rendering anything. And so I'm going to start by returning a material app. And let us just, what should we do first? Let's do the weather page itself. So let's do home, and I'm going to do weather page. And I'm going to create a weather page. So our app is going to be split in two parts, right? It's going to be weather, and it's going to also be search, right? So the weather page is going to just show us the weather, and the search page is going to allow us to search for cities so that we can update the weather. So I'm going to go into weather, and I'm going to create weather page.dart. And weather page.dart is going to basically be responsible for rendering the actual weather that we give it. So let me make this stateless weather page, and then let's do a sanity check and make sure everything is rendering properly. I'm just going to return text weather page. Actually, let's do a scaffold because we probably want to, yeah, let's do a scaffold. And then, I don't know, let's do the typical like app bar, title, text, Flutter, weather. And then body, let's do center, whatever, weather page. Let's just make sure that we can see our weather page, right? I'm going to do the exports file again in weather. So I'm going to export weather page. And now in our weather app, we can import the weather page. And if I save, yay, I see the weather page. So that's good. Now the first thing that we need to do is we need to figure out how our weather page is actually going to hook up to our search page, right? So let's define the search page really quickly as well. I'm going to call it city search. And let's start off with just city search. Let's make it another stateless widget. And then here, let's do the same thing. I'm literally going to copy weather page and drop it in city search. We're going to call it city search, whatever, right? So we got city search. So now I'm going to add the search.dart file here so that we can import the search functionality all at once as it gets bigger. And the one thing that I'm going to do that's special here is I know that we're going to route to here. So we're going to cover how to do routing. One way, this isn't the only way, but this is a thing that I find nice, is if you define a static route method on your pages that you want to be able to route to, you can return the route. So we're going to return a material page route. A material page route takes a builder, and the builder has to build the widget So we're going to just build weather page. And now we have this route on weather page. And so, oh, and I should have renamed this. This should be called city search. There we go. Sorry, going too fast. And so now we have a route on city search, and from weather page, I can add a floating action button. Floating action button. We can give it a child icon, or let's just give it an icon, icons search, and then on pressed, we're gonna do navigator of context, which is gonna look up the nearest navigator, and then we're gonna push city search dot, I need to import city search dot route. So if I update now, I see this floating action button. If I click it, it takes me to the city search screen. And from the city search screen, I can go back, right? Pretty cool. So we've wired up some basic navigation. Let me stop and check the questions. Explain the required, but I didn't understand. Okay, so yeah, required is basically an annotation that will give you warnings if you forget to provide a named value. So when you create a constructor, so if I go to weather app, the constructor has named parameters, right? So everything is curly brackets. Yeah. So let's answer this question because I think it's important. So everything is in curly brackets, right? And so named parameters are by default optional. You don't have to provide them. So for example, if I remove the required keyword here and save, I can go to my main.dart and I can forget to pass in weather service and nothing is going to happen, right? Like there's nothing telling me like, hey, Felix, you forgot to add the weather service. If I go now back to the weather app and I add the required keyword and save, now you'll immediately see I have a warning saying weather service is required. So the required keyword is there to help you and remind you when you forgot to pass required information if it's named. So it's really good to use whenever you have a named argument that you want to actually like be 100% provided every single time. So good question. Let me make sure there are no other questions. Cool. So let's carry on. So we need to figure out now how to actually make or how to get input from the user, right? So we're going to need to make our city search basically take a form or have a form that the user can fill in, and then we're going to return the city that the user typed in. So in order to do that, I'm going to use this shortcut to convert to stateful widget. You'll see why in a second. So I've made my city search into a stateful widget, and in the state, I'm going to create a text editing controller. So I'm just going to call it controller, text editing controller. So the text editing controller is going to keep track of the text form field that we put in. So I'll show you now. We're going to swap out the body for a row, and our row is going to have, how do we want to do this? We can have children, and then we're going to want our input field, and we're going to want our button. So I'm going to do the input field first. So we're going to do a text field. We're going to pass the controller that we have, and this is going to be responsible for keeping track of what the user has typed in. So that's what the controller is there for. And the decoration, we're going to make this look a little nicer, not too nice, but a little nicer. We're going to give it some label text. Label text, and this is going to just be an indication of like what this input field is for. You'll see in a second, and I'll give it also a hint text, and this is going to be a hint to the user for like an example of what they can type in. And with that, I will also add, or let's just save that. Let's make sure that this is all working. So now if I go to the city search screen, we get an error. Cool. We need to wrap our text field widget with an expanded. There we go. And that's because we need to tell it to fill the entire row. So now we have our text input widget. We have the label city, and we have the hint text Chicago, right? So we're telling the user what this is for. I'm going to add an icon button. Actually, let's make this look a little nicer. Let's give some padding. so that it's not going all the way to the edge. And then let's throw in the button. So we're going to use an icon button, and we're going to say for icon, we're going to just use the same icon search. And on press, now here's the key. When the user presses the search button, we want to take whatever the user typed into the text field and give it back to the previous screen. We're going to basically pop the screen off of the navigation stack and return the value that was typed in. And so the way we do that is we can do navigator of context dot pop, and in pop you can pass arguments. So we can pass controller dot text, and that's going to give us, or that's going to give whoever pushed the screen the text back. And one thing that's good to do with this is annotate the route to say that this route is returning a string. So we're saying that whenever this route is popped, it's going to return a string result. And same thing here. So now from our weather page, we can adjust our onPressed function. This is going to be a bit more complicated. So I'm going to make it async. I'm going to await the result, and I can get the result, right? So city now should be a string because we said our route returns a string. And let's just print city, city. So if I do a hot restart, I should be able to come over here, type Chicago, hit the search button, takes me back, and you see hopefully down here, Flutter printed city : Chicago. I have a lot of stuff covering the terminal. Let me hide the terminal because we don't really need the terminal right now. You all saw the terminal. So there we go. You can see that we're getting the city back from the route that we pushed. So that's great, right? Our city page is pretty much good to go. One thing that we need to do though is we need to remember to dispose our controller. And that's just saying when this stateful widget is removed from the widget tree, also remove all the resources for the controller. So that's something you should remember to do. But yeah, now we're popping and returning the value. So now we need to actually do something with the value. So in our weather page, we have to have some way to actually get weather, right? So I'm going to define using a type definition. You'll see in a second. So you can create a type definition using the type def keyword. And we can say a weather getter is going to return asynchronously a weather object, and it's a function that takes a query. And the weather object is coming from our service. And so we have this type weather getter, which is any function that takes a string and returns weather. And we're going to say our weather page needs a weather getter. So weather getter, or maybe let's call it get weather. That'll be a little easier to understand, hopefully. So yeah, so we have this weather getter. We're going to say that it's required, right? Because we always want to have a weather getter. It's really hard to say. Get weather is not null. And so now we need to basically pass in that weather getter. So get weather, what is that going to be? It's going to be weather service dot get weather. So we're just passing in the function from the weather service into weather page. And so now weather page can call get weather anywhere. So I can basically now start calling get weather and start accessing the weather information, but we're going to need to start keeping track of that information. So I'm going to refactor this widget to be a stateful widget. Let me pause and make sure there are no questions. Cool. So yeah, no API key for meta weather. Yeah, so now we've made this weather page a stateful widget, and we're going to need to keep track of some state. So I'm going to create a models folder inside of weather, and I'm going to create a weather state.dart, and that's going to represent the state of our UI. I'm going to create exports file again for convenience, and now let's define the weather states, right? So I'm going to define a base class weather state, abstract class, and we're going to have different types of weather state. So we're going to have weather initial, extends weather state. Hold on, do we have a question? Another question. Most of the time when creating a form, we use final. Oh, so for the text controller, like I said, we need that text controller because later on we want to be able to access the value that the user typed into the input field. So without that text controller, we wouldn't be able to access the value that the user had entered in the text field. So that's what the controller is for. There are other ways to get it. There's like onChanged for the text field, but then you'd have to save it manually every time. The controller does it for you. So it's just a convenient way to access the value of the text. So if I type Chicago in, I want to get the value Chicago, I can do that by accessing the text property on the controller. So good question. Going back to the different weather states. So this is the state of our UI, right? So we can have the state where like the user hasn't typed in anything in the city. So that's going to be the initial state. We can have the state where the user has entered a city, but we're in the process of requesting weather from the API. So I'm going to call that weather load in progress state. We can have the case where we got weather, right? Weather load success, weather state. And we can also have the case where we didn't get weather, right? Weather load failure. For whatever reason, right? It could be like you don't have internet, it could be the API failed, it could be whatever. And in weather load success, we want to have an actual weather object, right? Because if we loaded the weather, we need the weather that we loaded. And we'll create a constructor. Cool. So again, initial is going to represent the state of our app when their user hasn't typed any city. Load in progress is going to be when they've typed a city like Chicago, but we're still searching, like we didn't get a response back from the API. Load success is going to be when we got a response back with data, and load failure will be when we got a response back without data. Something went wrong, right? If it wasn't a 200 in the API, for example. And so now that we have this weather state, we can say our, let me add that to the app exports actually. Need to keep up with the barrel model, oops, models, dot. Oh, sorry. Export weather dot. There we go. And then now we should be able to define weather state. I'm going to call it weather state. Let's import it. So it's going to be coming from models, blah, blah, blah. It just should be coming from app. So am I not exporting models? Yeah, I'm not exporting models. Export models. There we go. Cool. So weather state should be able to come from app. And we need to initialize this, right? So we can use init state, and we can say when this widget first gets created, we're going to say it's going to equal, what do we call it, weather initial, right? So weather initial, everything's good. We have another question. Okay, so yeah, a couple questions. Am I developing Android or web? So I'm using Flutter. I'm running it right now on macOS as a macOS desktop application. But since it's Flutter, you can run it for Android, iOS. You can run it on web as well. So it's one code base that will work on all those platforms. And super key, what does that mean? It's a good question. So every widget typically has a key. You don't have to assign the key if you don't want to, but it's good practice to pass this key in so that later on in your application, you can uniquely identify this weather page. And that'll help you with things like writing tests and finding that widget later on. So for example, here when I create weather page, I can assign a key, whatever, weather page. And then later, if I'm writing tests, I can find this exact widget by this key if I want to. So it's just good practice to add keys to your widgets and pass the key to the stateful widget superclass or stateless widget superclass so that that key is associated with that widget, and then later on you can look it up if you wanted to. If you don't pass it, it's fine, it's not required, so it doesn't hurt anything, but it's just a good habit. And it's also generated. Like if I remove this constructor and I do create constructor, it generates it for you. So you don't have to type it out, and it's just a good practice to do that. Good question. So now we have our weather state, right? And what I'm going to do now is I'm going to create a widget called a weather view. And this is going to be responsible for, based on the state, rendering different widgets. And this is just for organization. So weather view, and it's going to take a weather state. It's going to be required, right? We can also assert, for the sake of time, I'm not going to write the asserts. And now here we can do current weather equals, or let's just say current state equals weather state. So we're going to get the state at this point in time when this build method is called. And then we can start doing checks like if the current weather state is weather initial, do something. Else if the current state is weather load in progress, do something else. Else if the current state is weather load success, do something else. Else it's a failure, right? So we need to come up with all the widgets that we're going to render in here, and we're going to need to return them. So I'm going to create another folder inside of weather called widgets, and I'm going to quickly define all these widgets. So I'm going to create widgets.dart, which is going to export all of them. And the first one that we're going to do is going to be for, let's just do the empty state. It's going to be the state when you have nothing yet. So we're going to call it weather empty.dart. And weather empty.dart is basically just going to be a stateless widget, weather empty. And we're going to return a column. And you'll see once we do this one, all of them will be pretty much the same. So we're not going to spend that much time. But we're going to make a column. We're going to give it some children. So we're going to give it, I'm going to copy some of this so that I'm not typing it all. And we're going to access the theme so that we can give it a text style of headline 5. So it's going to look bigger. And then the other thing we want to do here is we want to make the column take up as little space as it needs, and cross-axis alignment, we want to center it. So we have our weather empty. I'm going to add the weather empty, and then we're going to create a couple of these. So I'm just going to literally copy these because they're all going to be the same. And let me see, there's another question, it looks like. Oh no, we're getting low on time, so we're wrapping it up. So weather error, it's going to be the same thing. It's a column. It's going to access the theme, and we're just going to put a little monkey with his hands covering his ass because we messed up and something went wrong, right? And I'm going to export weather error. We have the weather loading, so I'm going to do weather loading.dart. Paste that in. Again, another stateless widget. Again, we're accessing the theme so that we can style the text. And this time we're putting a little emoji of some clouds and a sun. We're saying loading weather, and then we're putting a loading indicator down below. So that's all weather loading, just a basic widget. So weather loading. And now the real guy is this weather, the one that we're going to render when we actually have weather. So weather, we're going to call it populated.dart. And I'm going to drop it in just because we're running low on time, but I'm going to walk through the code in a second. So weather populated is going to be another stateless widget that takes a weather object, right? This is the weather object that we defined in our service. And it's going to use a stack. And the reason it's going to use a stack is because it's going to layer things on top of each other. So we're going to have a background. And our background is going to basically be a container that has a gradient of different colors depending on the theme of our application. This is just like a nice touch, not necessarily required to make the app work or anything. But we have this background widget that's going to give us a gradient of colors. And then on top of that background, we're going to have a column, and then we're going to have the weather icon that's based on the condition. So if it's rainy, it's going to have a little cloud with rain. If it's sunny, it's going to be sun. We're going to have the name of the city, and then we're going to have the temperature. We're going to go to 2 precision units, and then this is always in Celsius from the API. So we're going to tell the user that it's in Celsius so that they know. And that's pretty much it. Weather icon is just calling toEmoji, which is converting the weather condition to a different emoji. Nothing special going on there. And yeah, that's pretty much it. So I'm going to export this last one and hook everything up so that we can see it all running before we run out of time, hopefully. So now in our weather page here, where we had all of these cases like if this, then that, we need to actually return those correct widgets that we just defined. So let's make sure I'm exporting widgets.dart. Cool. And now, so if our state is weather initial, we're just going to return weather empty, right? Because that's the empty state. If we're loading, we're going to return weather load, weather loading. That's what we call it. If it's success, we're going to return weather populated, and we need to pass the weather. And then if it's something else, right, the only other thing is whether if it's an error. So we're just going to fall back to the error case. If it's something else that we haven't handled, it's an error. And we need to actually put this weather view somewhere, right? So let us do that really quick. So we're going to drop in the weather view instead of the body that we had before. And then we're going to say weather state is weather state. So if I save this up now, we should see something went wrong. Nice. Let's refresh. There we go. Please select a city. Cool. So one thing that I forgot to do is I forgot to center the weather view. So I'm going to center it quickly. So we have the please select a city, right? Because we're starting off in weather state initial. And now we need to actually make the call. So when we get a city back, from the navigator, instead of printing it, let's do, we can do widget dot get weather, right? Because we're calling the get weather from the weather page. So we can access it doing widget dot get weather, and then city, right? And that's going to return, a future. So we can use the dot then, and that's going to give us weather. And we can also do a catch error. And on error, if we have anything, it doesn't really matter. We're going to need to handle it, right? So when we get weather, that means if we're in the then, everything went properly, everything succeeded. So we can use set state to change our widget state. Instead of weather state being initial, we're going to make it equal to weather load success. And then we're going to pass the weather in, right? If it failed, then we're going to set state, but we're going to say it's a load failure. And the other thing that we need to do is right when we're about to make this call, we can do a set state and say our weather state is equal to weather load in progress, right? So as soon as the user types in a city, we're going to tell the user, okay, we're searching. We're going to execute the search. And then if the search succeeds, we're going to say, okay, we're a success with that weather object. And if it's a failure, we're going to say we're a failure with that weather object. So if I do a hot restart now, and I do a search, and then I type Chicago, we get an exception. Oh, fun. I forgot to mention this. I'm running this on Mac OS. And so on Mac OS, there's one thing you need to do. And that is you need to do this permissions thing where in, let me find it, in runner debug entitlements, you need to give it permission to use the networking client. So I'm going to quickly just save that and restart my application. While that's restarting, I'm going to check to see if there are any questions. So what does init state do? Init state is called only once when the widget is first created. So you could put stuff in there that you need to initialize any state information for that widget. It's only guaranteed to get called once. And set state allows you to tell Flutter, I've changed some property about this stateful widget. Please re-render or rebuild. So that's what those are, and those are only for stateful widgets. If you have stateless widgets, you don't have an init state and you don't have a set state. So good question. Now, yeah, we have our app running again. So now I should be able to go in here and I should be able to type Chicago, search. We get our loading state, right? And yay, we got Chicago. It's rainy, 15 degrees. Um, and if I come here and I do, I don't know, Los Angeles, search, we're loading again. Los Angeles, yay, it's sunny, 20 degrees. And we don't have too much time. Let me see how much time we have left. We have 8 minutes. I'm going to try to quickly do the theming in the last 8 minutes. So we want to try to change this gradient that we have in the background to reflect the actual weather, right? Wouldn't that look cool? And so in order to do that, we can come back to our material app in our main weather app where it all began. And we can basically convert this into a stateful widget. And in here, we're going to keep track of the actual theme color, right? Because the theme color is going to be changing, we're saying. And so if I take this really quickly so I'm not typing it all. Actually, I guess I can type part of it. So we're going to keep track of the primary color, right? That's going to be the thing that's going to be changing. And so that's what we're keeping track of as state. And then we're going to say our theme is going to use the primary color from the state. Cool. So that's nothing exciting. Like everything's fine. Every time you change from stateless to stateful, you have to do a hot restart. So that's what that is. And then now we need to expose an onWeatherChanged function. So we need to have some way for the weather page to tell the weather app that the weather changed, right? Because the weather app has no idea. So the way that we can do that is we can define something called a value setter. And a value setter is just something that's built in. It's just a type definition that says it's a function that returns this type, and this type could be anything. So we're going to say our weather page has an onValueChanged function. On weather changed, yeah. And so when the weather changes, right, which is over here, here we can call widget.onWeatherChanged and pass the weather in. So now we're telling our parent widget, hey, onWeatherChanged, and here's the weather. And so in the weather app itself, we can now get notified anytime the weather changes inside of the weather page. And now here we can do stuff with it. And so here we can do a quick extension, which I'm going to copy. And we're saying we're going to do an extension on weather, and we're going to do an extension to convert weather to a color, right? So pretty simple. If it's clear, we're going to use orange. If it's snowy, we're going to use light blue. If it's cloudy, we're going to use a bluish gray. If it's rainy, we're going to do like a dark purple. And yeah, so now we can basically do set state, and then we can say our primary color equals weather.toColor. And that's it. So now I should be able to save. Let's do a hot restart. And if I come here and I pick Chicago, before you remember it was always blue, right? Our background was always blue. So now it's purple, right? Because it's rainy. And so we're using colors indigo accent. If I search Los Angeles again, I think it was sunny in Los Angeles. And we let it go. Yeah, it's sunny. So we get this orange accent. And if I do, I don't know, let's do some place where, Seattle maybe? Seattle, yeah, it's cloudy. So we got this cloudy emoji with the blue-gray. I want to show an error. So if I type something that's garbage, right, the city doesn't exist, what's going to happen? We're going to get exceptions, and then we get our error widget, something went wrong. So we know that our error case is also working properly. And yeah, so let me check questions. Extensions, can I explain them? So again, extensions are something just new in Dart that's fancy that allows you to add basically functions or like getters to a class or object that you didn't make. So this weather app class, it did not define the weather class, right? The weather class is defined in service weather.dart. It could even be defined somewhere totally different. It could be defined like in a different framework or in a different package. But But extensions allow you to say, okay, take that weather class and I want you to add this method or this getter to it. So now anywhere where I have a weather object, right? Like this is still a weather object that's coming from weather service, right? And weather service, the object there doesn't have a toColor, right? We never defined a toColor. But because we have this extension on weather that adds a toColor, now we can call toColor. Another thing you could do is you can literally write a function that's like weather toColor, right? And you can take weather. You can literally copy this code in here, and then instead of condition, it's weather.condition. And now we can just do weather toColor weather. And that's literally the exact same thing. Extensions is just like a nice convenient way to do it so that it reads a little nicer. It reads a little nicer to just do like, okay, I want to call toColor on weather. And extensions allow you to define that somewhere else so that you don't have to have a toColor, right? Because our actual weather model shouldn't care about colors. It just cares about representing the data that we have here. And also the extension, since I didn't name it, you can name it, like you can say weather extension. And now this allows you to import this extension in other places in your code base and reuse this toColor. But by not naming it, I've made it scoped to just this file so that only in this file I can call toColor on weather, nowhere else in the app. If I try to, like in the weather page here, let's see, where do we have a weather again? Here, we have weather, right? I can't do toColor, right? There's no such thing as toColor here. So yeah, that's what extensions are. And so yeah, to recap, let me just go back to a sunny day or like a regular case. We built a cool weather app. It's hitting the meta weather API. So if I collapse all these folders, we have the API layer, which is basically making the HTTP request to meta weather, right? We have the services layer, which is using the meta weather API, but then making it simple to use, right? So that when we're writing our Flutter app, we don't have to worry about, I have to make a location search call, I have to make a weather call, blah, 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 blah. And also it allows us to define a nice, easy to work with model. So this is a lot easier to work with than if I look at the model for meta weather, right? Like this thing is kind of ugly. It has a lot of stuff that we don't care about in the app. And also there's stuff that we want to simplify, right? Like we want to simplify to just these conditions instead of having all of these, right? Like snow, sleet, hail, blah, 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 blah. So it's just a nice layer of abstraction in between the API and the application. And then lastly, we have the application. So the application consists of our main. Our main we call run app with a weather app, and we pass the weather service. And then our weather app basically just uses that weather service to expose that get weather property to the weather page. And then the weather page exposes this callback function to the weather app whenever the weather has changed. We update the theme color whenever the weather has changed from within weather app. And then weather page can request weather whenever it needs it, right? So we use the get weather that's passed in from the parent. Also, we're using a navigator and navigating to a different screen and then getting the result from that screen. So there's a lot of complicated stuff here that's like all the stuff that you technically can like build really complicated apps with. Like this app is pretty simple, but all these same things apply when building even more complicated apps. So I think it's good to kind of go back over this at your own pace and make sure you understand it. And like I said, all the code is also, let me go back to the slides. All the code is here at GitHub. So the complete example, so you don't have to worry about if you couldn't follow along or if I was going too fast. And yeah, I think that's pretty much, let me check questions. Cool. I think, yeah, we just barely made it. We're 1 minute over. But yeah, thanks everyone for tuning in. If you have any other last minute questions, feel free to post them in the chat. Otherwise, I hope everyone enjoyed this. I hope they learned how to build a Flutter application that uses a REST API and handles some somewhat complicated logic and kind of looks nice. We could have made it definitely look a lot nicer if we had more time, but I think it's good for like whatever we had, an hour and a half. And yeah, thanks so much.